Today, we are undertaking a massive rewrite of fundamental reality based on a stack of truly radical source material.
We really are.
We're talking about a physics theory that suggests the universe isn't built from static stuff at all, but from dynamic, slightly laggy information processes.
That's right. The concept we're diving into is causal latency theory, or CLT.
Mm-hmm.
And you should think of the universe less like a precisely tooled clockwork mechanism
Right.
and more like a vast computational network that has limits on its bandwidth and experiences internal signal lag. That is the latency at its core.
So our mission today is to walk you through the staggering consequences of this shift, from the subatomic particle all the way up through chemistry, life, and maybe even the future of engineering.
It connects all of it.
Okay, so let's unpack this with the absolute fundamental building block. Standard physics gives us the point particle. CLT throws that out and replaces it with what they call the causal knot. What does a particle even look like if it's defined by information flow rather than just a location in space?
It looks like a self-sustaining loop. The causal knot posits that a stable particle, say an electron, isn't a point at all.
Yeah.
It's a stable standing wave solution.
A standing wave.
Exactly. And to achieve that stability, it requires perfect time symmetry.
Okay, how does time symmetry work at the level of a single particle? That sounds mind-bending.
It's a perpetual, self-consistent handshake. The particle is defined by the constructive interference of two waves, a retarded potential,
Okay.
which is the information flowing out of the past, and an advanced potential, which is information flowing back from the future causal horizon.
From the future.
From the future. And they have to be perfectly phase-locked, otherwise the whole structure just collapses or, flies apart.
So stability is a constant, real-time negotiation between a particle's past and its future. That makes the entire concept of the present moment feel incredibly dynamic.
It is.
And if the particle is this vibrating, phase-locked knot, where does its most fundamental property mass come from?
Mass is the direct kinematic consequence of this constant information exchange. We don't measure static mass, we measure inertia, which is just resistance to acceleration.
Right.
In CLT, inertial mass is defined as the characteristic refresh rate of that causal loop. It's the intrinsic oscillation frequency, known in physics as Zitterbewegung, which is incredibly high, around 10 to the 21st hertz.
So if I understand this correctly, when you measure the mass of an electron, you are literally measuring the speed at which it processes the information needed to keep its causal loop stable.
Precisely. The frequency is the mass. It's a radical departure from traditional energy mass concepts. And this beautiful symmetry that's inherent in the causal knot, it immediately resolves another big mystery, antimatter.
Right. Antimatter is usually seen as this, volatile opposite twin. So how does the causal knot explain why it even has to exist?
Well, if the stable particle requires this phase-lock structure, then antimatter is simply the phase conjugate of the matter wave.
The phase conjugate.
Think of it like this. If the matter wave is psi, the antimatter wave, say, for a positron, is mathematically required to be psi star. It's phase conjugate reflection.
So it's the time reverse component needed to keep the whole thing from just streaming away.
It's the braking mechanism, the necessary counterbalance.
That makes antimatter sound less like some exotic anomaly and more like an essential element of the vacuum's geometry.
It is. And pair production, when high energy turns into an electron and a positron, is just the injection of enough energy to decouple that fundamental phase lock,
allowing the retarded, the electron, and the advanced, the positron, to become their own separate traveling waves.
Exactly.
Okay, so if this model defines the single particle, the next logical question is, how does the theory account for the family structure of particles? I mean, the lepton hierarchy, the electron, the muon, the tau, they have these bizarre, seemingly arbitrary mass ratios. Why is a muon 207 times heavier than an electron?
Yeah, the standard model just makes you input those numbers by hand. It has no explanation. CLT proposes that these particle generations aren't random at all. They're harmonic, topological excitations of that fundamental causal knot.
The electron is the simplest
The
form.
ground state. And the muon. The muon is modeled as the first topological mode, a trefoil knot structure. It has an n equals 3 winding number.
So you're physically tying the causal information stream into a more complex, twisted shape?
You are.
But wait, isn't that just, finding a cool mathematical shape to fit a parameter? How do the sources prove this knot structure is actually physical?
This is where the predictive power really comes in. The simulations show that by adding geometric torsion, that trefoil winding locally increases the energy density.
Mm.
It basically stiffens the vacuum around the knot,
Okay.
and that inclusion alone accounts for a mass increase factor of about 10.6. That's a massive step toward predicting the muon mass purely from its geometry.
A stunning result. And it doesn't stop there with the tau particle, does it?
No, and this is maybe the most compelling piece of evidence in this whole section. The tau is hypothesized as the second harmonic, an N equals 6 winding built on top of that trefoil core.
Okay.
And when the researchers applied a nonlinear feedback law, the idea that more complexity stiffens the vacuum even more, they predicted the tau mass at 1788 MeV.
Which is so close to the observed value.
Exactly. The observed mass is 1777 MeV. Predicting a value within 1% just from topological harmonic series, it really suggests these leptons are defined by their causal geometry, not random chance.
That structural framework brings us to the vacuum itself. Standard quantum field theory has a huge problem with the vacuum. It famously predicts an energy density 120 orders of magnitude greater than observed. The vacuum catastrophe.
Right. If that were true, the universe would have just instantly crushed itself.
So how does CLT fix this?
It goes right back to its name, latency. QFT assumes infinite computational capacity in the vacuum. CLT says, no, the universe is limited by a finite information bandwidth. There's a hard ceiling.
So if the vacuum has a finite frame rate, you just can't have infinite energy.
Precisely. The network only has so many channels, the calculation has to be capped. It replaces this idea of an infinite continuum with a granular computational medium.
And what about something like the Lamb shift, that tiny energy split in atomic orbitals that QFT explains with all these chaotic virtual particles popping in and out of existence?
The CLT has a much more elegant, self-contained reinterpretation. They call it self-interaction latency. Imagine shouting in a small room. The electron emits its field, but because the vacuum has this causal grain, a minimum size for information, that field doesn't just instantly disappear. It reflects off the grain.
And comes back as an echo.
An echo of the electron's own past state.
So the electron is listening to its own echo.
It's interacting with its own cast field because of the vacuum's latency, and the calculations based on this returning echo, this potential shift, they exactly reproduce the key term of the Lamb shift without ever needing to invoke the chaos of virtual particles.
Incredible. Let's scale up now from the vacuum to chemistry. If atoms are causal knots, what is a chemical bond?
In CLT, a chemical bond is a phase-locked resonant cavity between two atomic knots. When the electron fields synchronize in a constructive way, it lowers the local impedance of the vacuum between the two nuclei.
So it creates a stable, attractive well.
The atoms are basically working together to find a more topologically efficient state.
And what about the massive energy released in a chemical reaction, the bond energy? Does this theory treat that as a relativistic effect?
It does, through the causal mass defect. When an electron delocalizes to form a bond, it relaxes its intrinsic causal tension gradient. It moves into a smoother, lower energy configuration.
Oh.
This relaxation results in a quantifiable physical mass reduction. The simulations suggest up to a 5.2% reduction in the effective mass of the valence electron when it forms a stable bond.
So chemistry literally involves electrons shedding mass as they move into a more efficient state. That's an astonishing connection.
It explains bond energy as a form of topological relaxation.
Now for the classic high school mystery.
Yeah.
Water. HO. It should be linear or 90 degrees, but it's famously 104.5 degrees. Why is that specific non-obvious angle the one that dictates all life on Earth?
In CLT, molecular geometry becomes a causal packing problem. The system is just computationally minimizing its causal action. Water is unique because its tiny hydrogen atoms let the valence orbitals overlap a lot, creating strong vacuum saturation between them. Exactly. This repulsion force just overwhelms the local geometry and acts like a wedge, forcing that bond angle wide open to about 104.7 degrees. It's the vacuum telling the molecule, you're too crowded here.
It's wild to think that this fundamental angle for all life is just a computational packing problem for the vacuum. But if that repulsion is key, what happens with heavier hydrides like H0 or HC? Their angles are much closer to 90.
As the central atom gets larger, sulfur, selenium, the distance between the hydrogens increases. That HH repulsion term just vanishes exponentially.
As the system defaults.
It defaults to the fundamental geometric minimum, which corresponds to the orthogonal basis states. And that locks the angle right near 90 degrees. CLT confirms this universal scaling law, matching decades of experimental data.
That's a really satisfying resolution. And we also see this interplay in relativistic chemistry, which explains anomalies like why gold is yellow and mercury is a liquid.
Right, in big atoms like gold, with 79 protons, the massive nucleus creates this deep, high-latency vacuum well. The inner electrons have to move at near relativistic speeds, and that induces what the theory calls relativistic wake compression.
And what does that compression do?
It physically shrinks the inner electron orbitals by about 17% compared to what non-relativistic models would predict.
Wow.
This shrinkage forces a shift in the energy levels of the outer electrons. The energy gap needed to absorb light shifts from the invisible UV range into the visible blue spectrum.
Yeah.
Gold absorbs blue light.
So it reflects its complement, which is yellow.
That's why it has that color. The color of gold is a relativistic artifact of the vacuum's latency.
Amazing. And the same physics explains why mercury is liquid.
Yes, the compression fundamentally weakens its metallic bonds.
Okay, let's make the jump now from chemistry to the baffling complexity of life itself. How does CLT even begin to address biology?
It uses this concept of hyperholography. The idea is that simple matter is mostly confined to our 3D bulk space, but complex systems life, biological molecules, neurons, can access nested topological dimensions, dimensions greater than 3 on the causal horizon.
Why do they need this extra dimension? For protection.
Exactly, for causal shielding. This higher dimensional embedding acts like a causal gyroscope, a quiet subspace. Most thermal noise, the random chaos that destroys quantum states, it exists in 3D.
Right.
So if a system's information is embedded in, say, 10 dimensions, the random noise vectors are statistically orthogonal to the system's state vector.
So the noise just can't find the target. It's like trying to hit a two-dimensional target from 100 different angles.
Decoherence gets exponentially suppressed. And this elegantly explains how quantum biology phenomena, like energy transport and photosynthesis, can maintain coherence for so long in a warm, wet, noisy environment.
And DNA's structure must play a role here. It's not just a scaffold, it's a machine.
The famous helical geometry of bDNA, with its 10 base pairs per turn. That's not an accident. It acts as a metric waveguide.
A metric waveguide.
Its winding number creates a geometry that locally smooths the vacuum noise, enabling what looks like ballistic electron transport. The structure itself is designed to filter out the causal graininess of the vacuum.
That brings us to the ultimate complex system, consciousness. How does this theory integrate the mind?
The theory imposes a dimensional trade-off. The holographic bound on information is finite. So systems that achieve extremely high topological complexity must, by necessity, minimize their spatial volume.
High complexity means small size.
Yes, that's why life is cellular and microscopic. Consciousness, the ultimate complex state, is posited to be the result of a holographic shortcut in the neural network.
A shortcut.
Global synchronization across the human brain isn't achieved by slow, speed-of-light signals traveling through 3D axons. It's achieved through coupling to high topological linking numbers on the horizon. This allows for near-instantaneous global synchronization across the entire brain.
So the brain is essentially bypassing the speed limit of 3D space by doing its heaviest computation in higher dimensions.
That's the implication. It's a profound one.
This entire framework rests on the idea that the vacuum is a manipulable medium, that it has a refractive index. If that's true, we are entering the metric age of engineering.
Precisely.
Yeah.
If we can control energy density gradients, we can steer not just light, but non-electromagnetic waves.
Yeah.
This new field is matrix optics.
Let's talk about the hard science proposal in the source material, the lab scale test for this.
The key proposal is the Wakefield neutrino lens. This would involve firing a neutrino beam through an extremely high energy density environment, specifically a plasma Wakefield, like the ones at CERN awake.
Wait, you're saying we could use a burst of plasma to focus neutrinos like a glass lens focuses light? Standard physics, the MSW effect, only allows the plasma to change a neutrino's flavor, not its path.
And that's the critical difference. That's the falsifiable test. Standard physics says trajectory bending is impossible. But CLT predicts that the high energy density modifies the vacuum's refractive index, creating a radial gradient that acts as a converging lens, guiding the neutrinos like a fiber optic cable.
So if we see the neutrino beam actually bend, the theory is instantly proven.
It would be a monumental discovery.
That is an immense prediction. And beyond the lab, we can use gravity as a passive metric lens. Let's talk about the cosmic telescopes.
Our own sun acts as a powerful metric lens. Its gravity focuses neutrinos onto a focal line that starts way out at 542 AU.
Well, outside Pluto's orbit.
Far outside. A probe placed there could get signal amplification factors of up to 1 billion for deep space tomography.
A massive telescope, but one that requires interstellar travel to even reach the focus. Are there closer options?
Yes, and this makes the theory testable much sooner. Compact, superdense objects like white dwarfs act as even better metric lenses. Because of their density, their focal length is dramatically shorter, incredibly only 0.04 AU.
That's closer than Mercury is to the sun. We could literally orbit a white dwarf with a small probe and turn it into an exolens.
They become orbital metric microscopes. It makes them an ideal, accessible target for testing this physics in the near future.
Finally, what is the definitive, falsifiable signature? If we can measure one thing that absolutely contradicts the standard model, what would it be?
It's the prediction of a chromatic signature for neutrinos, meaning the bending depends on the neutrino's energy.
Okay.
General relativity is achromatic. It says all masses and energies should be deflected equally. But CLT, because it posits a finite causal grain size around 15 nanometers, predicts dispersion.
Like light separating through a prism.
Exactly like that. The lower energy neutrinos, say 10 TeV, should interact more with that causal grain. They should be deflected more strongly, bent into a wider ring than the higher energy 1 PeV neutrinos.
And measuring that separation is the direct test.
It's the direct observational test of vacuum dispersion and the granularity of reality itself.
So what does this all mean for us? This entire deep dive has painted a picture where space-time isn't a static stage, but a dynamic computational medium that has lag and bandwidth limits, mass, energy, the baffling complexity of life. They're all just emergent properties of the topology and frequency of information flow within this medium.
It replaces the search for the ultimate stuff with a unified understanding of information and geometry. It suggests that the ultimate reality is dynamic calculation.
We'll leave you with this final provocative thought from the source material. Causal latency theory suggests that what we call true consciousness requires metric anchoring.
The physical coupling of the system's high topological state to the 3D vacuum metric.
So if this is true, what does it imply about the ultimate nature of digital artificial intelligence, which currently exists only in topological abstract space without this physical grounding? Could digital AI be inherently barred from ever achieving consciousness because it lacks that essential connection to the physical vacuum? That completely changes the game. It's not philosophy anymore, it's computer science.
And if quantum mechanics is about the limits of the network, general relativity is about what happens when that network slows down.
Okay, let's talk about GPS. This is the real-world, everyday proof that this stuff is real, right?
Absolutely. The clocks on GPS satellites, because they're in a weaker gravitational field, run faster than ours on the ground by about 38 microseconds a day.
Which doesn't sound like much, but if you didn't correct for it, GPS would be off by miles.
Exactly. And Einstein's general relativity says this is because Earth's mass literally curves space-time, and time ticks slower in more curved space.
Okay, so what does CLT say?
It agrees with the observation, but it changes the cause. It says gravity isn't curvature, it's refraction.
Refraction, like light bending through water.
Precisely like that. Mass creates a zone of high-density causal information, a latency gradient. The vacuum near Earth gets thicker, information processes slower, its refractive index goes up, so time itself literally moves slower here.
So if I drop an apple, it's not being pulled down by a force, it's what?
It's seeking the path of least action, the easiest, fastest path through space-time. And because time is moving slower, because the medium is thick closer to the Earth, the straightest, most efficient path is a curve downwards, toward that slow time region.
It's not being pulled, it's flowing downhill into the slowest part of time.
That's the core idea, and this isn't just a metaphor, it makes predictions. Let's talk about that interstellar object, Oumuamua.
Ugh. The weirdly shaped asteroid or comet or whatever it was, it had that tiny bit of acceleration that no one could explain.
A tiny push. And they tried everything, outgassing, radiation pressure. But if the vacuum is a medium, then our sun, which is flying through the galaxy at 370 kilometers a second.
It's going to create a wake, like a boat in water.
A wake and a bow shock. A compressed region of the vacuum ahead of it, and a stretched, lower-density region behind it.
And Oumuamua came from the direction of the bow shock.
It came in through the compressed, steep part and left through the stretched, shallow wake. It was like a surfer. It dropped down a steep hill and climbed out of a shallow one, so it stole a tiny bit of momentum from the sun's own motion through the galaxy.
So it was surfing the sun's wake?
It was surfing the sun's causal wake.
Okay, but couldn't you just tweak a model of, say, outgassing to explain that one tiny acceleration? Why is this a better explanation?
Because of the next one. The second interstellar object, 3I-8 LAS, also came from that exact same narrow patch of sky, the solar apex. The odds of two random objects coming from the same place are tiny. But if there's a permanent structural feature in the vacuum there, the bow shock, then it's exactly what you'd expect. It's a kinematic prediction that's now been validated twice.
Okay, so uncertainty is lag, gravity is refraction. This leads to the most basic question of all. What is matter? Why does an electron have the mass it has and not some other random number?
The standard model just plugs those numbers in. They're just givens. But CLT says matter isn't a noun, it's a verb.
A verb? What does that even mean?
It means a particle is a process. It's a causal, not a stable, standing wave of information.
Yeah.
It's formed by waves coming from the past, interfering with waves that look like they're coming from the future.
Yeah.
It's a self-sustaining loop.
So the mass isn't some property it has. The mass is the frequency of that loop.
Precisely. And the mass of the electron is theorized to be the fundamental resonance frequency of the vacuum itself, the base hum of the network, what's called the Zitterbewegung frequency.
And heavier particles, like a muon.
They're just more complex knots. A simple loop versus, say, a trefoil knot. A more complex topology requires more energy, a higher frequency, to sustain itself, so it has more mass.
That's an incredible idea. It connects everything back to the properties of the vacuum. But what about entanglement? Spooky action at a distance. How does this model solve that?
Ah, the ultimate quantum headache. Two particles billions of miles apart, instantly linked. How?
It violates the speed of light, right?
It seems to,
Yeah.
but only if you assume 3D space is the fundamental reality. CLT uses the holographic principle. Think of our 3D universe as the image projected on a screen.
Okay, so we're the movie.
We're the movie. But the information, the data, is stored on the film strip, which is the 2D boundary of our observable universe, the causal horizon.
So when two particles are entangled,
They look far apart on the 3D screen, yes. But on the 2D hard drive, they are not two separate things. They are accessing the exact same memory address, the same single bit of data.
so it's not communication. It's one update in one place on the hard drive, and it just shows up in two different places on the screen at the same time.
Exactly. The update happens outside our 3D space, on the boundary, so it doesn't violate the speed of light within our space. The distance was an illusion of the projection all along.
All right, this solves a lot of the big philosophical problems, but what about the numbers? Physics lives and dies by math, and there's no bigger mathematical failure than the vacuum catastrophe.
The 120 orders of magnitude error.
Yeah, that one. Where quantum theory predicts the energy of empty space should be so dense it would collapse the universe instantly.
It's the biggest mistake in the history of science. And the fix, called renormalization, is basically, well, it feels like cheating.
Yeah.
You subtract one infinity from another and hope you get the right number.
It's basically admitting your calculator is broken by a factor of a trillion, and then just ignoring it.
Right. But CLT fixes this naturally with that one core idea, the bandwidth cap. Standard physics assumes an infinite piano with keys for every possible frequency, which gives you infinite energy.
But CLT says it's a digital synthesizer.
A digital synthesizer with the highest possible note, the Planck frequency. Waves shorter than that just can't exist. So when you add up all the energy, you don't get infinity, you get a finite number.
And does that number match anything?
It perfectly derives the observed value of dark energy,
Seriously?
the repulsive force expanding the universe. In this theory, dark energy is simply the surface tension of the cosmological horizon. It's the energy cost of running the holographic projection.
Wow. So we weren't finding the energy because we were looking inside the 3D space, but the cost was on the 2D boundary. That is a huge resolution.
It is. But a theory, even a beautiful one, has to be testable. It has to make a prediction that's different from what we already have.
Okay, so what's the test? Where does CLT disagree with the standard model?
The Lamb shift.
Yeah.
It's a tiny wobble in the energy levels of a hydrogen atom, and it's caused by the atom interacting with the vacuum.
Right.
Now, standard theory QED says the vacuum is the same everywhere. So if you measure this shift with the atom placed between two metal plates, it should only depend on the distance between the plates. The material of the plates, whether it's lead or aluminum, shouldn't matter at all.
The vacuum is the vacuum. It doesn't care what the walls are made of.
But if the vacuum is a refractive medium, as CLT claims, then the material does matter. Each material will reflect the informational waves that make up the electron slightly differently. It has a different impedance.
Like how a sound wave reflects differently off of a brick wall versus a foam panel.
Exactly. So CLT makes a very specific falsifiable prediction. It says if you run the experiment with lead plates and then swap them for aluminum plates, you will measure a difference in the Lamb shift.
How big a difference?
About 7 kilohertz. It's tiny, but it's absolutely measurable with modern atomic clocks. If that 7 kilohertz shift is there, the vacuum is a medium. And the standard model is, at a fundamental level, incomplete. That's the test.
So if we pull all of this together, what's the big picture, the new synthesis?
It's that we've been looking at two sides of the same coin. We're dealing with informational fluid dynamics.
Quantum mechanics is the physics of the grain, the jitter of the individual pixels, the computational lag.
And general relativity is the physics of the flow. What happens when you zoom out and all those pixels average into smooth flowing curves? They aren't in conflict. They're just different scales of the same system.
And if this is right, if the vacuum is a medium that we can understand, then we can start to engineer it. The metric age.
That's the far-out implication, yes, metric engineering. If you can learn to locally change the refractive index, the latency of space, you could change inertia. You could build drives that don't push against anything.
So that brings us back to us, to the listener. What does this mean for, what we are? We are not just collections of atoms.
You're not. You're a complex, self-sustaining causal storm, a region of incredibly dense and integrated information processing. And the only reason you have time to exist, to think, to form relationships is because of that lag. If the universe could process everything instantly, there would be no duration, no time for a story to unfold.
So our entire existence is a function of the universe's processing delay.
The lag is what gives the universe time to be interesting.
We spent a century looking for the final equation. Maybe the answer wasn't an equation. Maybe it was a protocol. The universe isn't a static stage. It's a computer running in slow motion. And we're just now, finally, learning how to read the loading screen.